Here is a question from NLM. This is the famous monkey problem. So let me tell the concept that is involved before solving this question. The concept that is involved is that when we solve these monkey climbing problems, we need to find the acceleration of the string. In most of the cases, the acceleration of the monkey is given with respect to the string, but the string itself will also have one acceleration, and we need to find that acceleration to solve this question. But for the perspective of this question, the this question is pretty easy in the sense the way the question is framed. Let me tell why. One thing that you must know is that when a monkey is climbing, say the legs of the monkey, the monkey moves due to the presence of friction in the leg. The frictional force acts due to which the monkey is able to move, and the frictional force act on both of the surfaces. So the tension that we take here is essentially the frictional force between the legs of the monkey and the string. So we write that that tension is actually the friction. We do not usually write the friction, we denote it by T only for convenience. And one important thing that is, since the string is ideal, that is massless, so tension at every point must be same. If here it is T, then here also it must be the same tension, that is T. And since this pulley is massless, so here it should be 2t, and here also it should be 2t. So that was the main thing. And why this question is a bit easy to solve, because here the acceleration of this monkey is given with respect to the ground. Its relative acceleration is not given. So it's easy because from the ground frame only. If I write the equation from the ground frame, drawing the free body diagram, see here 2 mg force acts, here t acts, and it is moving with an acceleration 2 a naught, that is from the ground frame. So I can write t minus 2 mg equal to 2m into 2 a naught. So I have got the value of the t. I have got the value of tension. Now, if the acceleration of monkey A with respect to ground is a, let me denote it as A subscript capital A, that is the acceleration of A with respect to ground. Then I can write that is t minus 4 mg equal to 4m a. Since I know the value of the t, I know value of A subscript A. So as I know that, it is asked that what is the time taken by A to reach the pulley P. Time taken I can write as A equal to, from the ground frame, half initial velocity is 0 t square. So time taken will be basically 2L by AA. Since I know the value of t, I know value of A subscript A. So I know the value of time. So it is done in one line only. But say I want to solve this whole system. Like I'm not interested in what is asked. I need to solve this whole. I need to find the all other quantities that are involved. So for that, to solve in general, what I will do is I will assume that the acceleration of string here is A. The acceleration of the string is also moving. So the acceleration of the string is A. Now see, this pulley is fixed pulley. Okay, by the way, one thing that you must know, that it is a continuation from the last video. That is, I have written that for x, you can also differentiate it and get velocity, and finally you can also get acceleration. If this is a1, this is a2, and this is a3, then a1 equal to a2 plus a3 divided by 2. Right, and similarly, it has 2 degrees of freedom, means we need to know two of the three quantities, and only then can we determine the value of the third quantity. Now this is a fixed pulley, so if this is going up by A, so this one will come down by A. This one comes down by A. Now this is a moving pulley, so this one we cannot write A. Say this is A1, this acceleration is A1. Then we can write it as 2A1 minus A. Right, 2A1 minus A. Now this is a fixed pulley again, so it is going down, it is coming up. 2A1 minus A. So here it is 2A1 minus A. Let us say that this is A2. So this one will be 2A2 plus A minus 2A1. Right. And here it is a fixed pulley, so same thing will carry forward here. 2A2 plus A minus 2A1. That is the acceleration of the string in this region. acceleration of the string in this region, and we know the relative acceleration of the monkey, so we can find the value of a subscript a. But I have told that in this question we can find it directly only, as the question was framed in a much simpler way. And if we wish to calculate a1 and a2, then we can also do that pretty easily. Write the equation, free body diagram of this system. We can write it as mg minus 2t equal to ma1. We know the value of tension, so we essentially know a1. Now if we wish to calculate a2, then we can write 2t minus 3 mg, 2t minus 3 mg equal to 3 ma2. Since we know t, we also know a2. So this system is solved for this question.